All right, so today we're going to talk about equations that have weird looking answers where it may not have an answer or it may have multiple answers. Normally, for an equation, and I'm going to give you something like this. Normally, for something like this, if I were to get rid of one of these variables, say the 2x, I would end up with 5 equals to 2x minus 9, and then add 9 to both sides. I have 14 equals to 2x. And when I divide both sides by 2, I'll just get an x of 7. So normally we end up with just one solution or one answer for each problem. And when I take the 2x plus 5 and set it equal to the 4x minus 9, and I plug in an x of 7, so change that to a 7, and then I'll change this to a 7. I will end up with 2 times 7 plus 5 equals to 4 times 7 minus 9. And as you can see, I will end up with the same thing on both sides, 19 equal to 19. So in other words, 7 is the only thing that makes this side of the equation equal to that side of the equation. 7 is the only answer, so we say 7 is the one answer to the equation, to this equation here. But sometimes these equations don't have just one answer. Sometimes these equations have no answer whatsoever. That means whatever you put in for the value of x, it will never make the left side of this equation equal to the right side. There is no x value. There is no one solution. There's no solution. There's no answer that'll make this side equal to this side. And sometimes any number you put in for x will make this side equal to that side. When any number works, we say there's an infinite amount of solutions. Okay? So let's just take a look and see what they look like when our equation has no solution or an infinite amount of solutions. And make sure you're pausing the video, guys. So you have to go back and rewind it. Go back and rewind it because I'm going to need you to take notes, okay? And let's solve this one like we normally do. So we already know case 1, it can have one solution. We've been solving those already, okay? All right, now if I solve this the way I normally would, negative 4 times 2x is negative 8x. Make sure you're taking notes. Negative 4 times positive 1 is negative 4. Set it equal to negative 8x minus 2. Now, if you notice, there's a variable on the left and a variable on the right, but they are exactly the same. You have the same variable on the left as you do on the right. Let me show you what happens when you try to get rid of one of those variable terms. Negative 8x changes to positive 8x if you want to get rid of a variable term. But this goes left, that goes right. We end up with 0x. We don't put 0x minus 4. We just say these cancel and bring down negative 4. This goes left, this goes right. You end up with 0x, but we don't put 0x minus 2. We just bring down negative 2 and say those cancel. But negative 4 does not equal to negative 2. Okay? So there is no answer. There's no x value. Matter of fact, my x's cancel. And then the statement that I got was a false statement. Negative 4 does not equal to negative 2. When your variable terms cancel on both sides and you end up with a false statement, we say there is no solution. In other words, there's no number you could put in for x that will make the left side of this equation equal to the right side of that equation. Now, sometimes instead of writing no solution out in words, we just do a circle with a slash through it. That also means no solution. So case 2 is there can be no answer to an equation or no solution. Case 2 happens when, again, the variables cancel on both sides, okay? And let me make sure I write that. Your variables are going to cancel. I'll say variable terms. And the leftover numbers don't equal, or the leftover statement is false. All right, that's how we get a case 2. But again, if you're looking at case 2, the variable terms have to cancel on both sides first before you can possibly get a case 2. And the leftover numbers will not equal, okay? In case 1, you still got an X. One solution. In order for case 1 to happen, a variable term has to remain. In other words, variable terms don't cancel on both sides. So for case 1, again, your variable terms don't cancel on both sides. You're going to have a variable term left. You can get rid of from one side, but you won't be able to get rid of it from the other side. You have a variable term left. Basically, you're going to end up with a two-step equation with a two-step or a one-step in order for case 1 to happen, for you to have one solution. But for case 2 to happen, which is no solution, your variable terms are going to have to cancel on both sides, and the leftover numbers don't equal. Now let's look at case 3. An infinite amount of solutions. Let's see what happens. All right, I'm going to bring this down. I can't make it any shorter by combining any like terms. I'm going to use the distributive property, so that's 3. Here, that's negative 9x, and bring down to negative 8. On this side, I'm going to combine like terms. So that's going to end up being, that's to the right and that's to the left. It's going to end up being negative 5 minus 9x. And I bring down negative 5 minus 9x. Now I'm going to show you something on this one. The variable terms are exactly the same. But if you also look, the constants are exactly the same too. It's the same problem, the same expression, just on different sides of the line. One expression is on the left and the other expression is on the right. Now be careful, because when we were over here, although the variable terms may have been the same, the numbers were not the same. But if you look on this problem while I was just working, the variable terms are the same and so are the numbers. So I'm just going to solve this like a regular problem. If I get rid of the variable from one side, I just need to change the sign. But what's left is negative 5, because these cancel equal to, and again, these cancel negative 5. So here, in this particular case, where I end up with, and when the numbers that are left over equal, we say it's an infinite or infinitely many. It's infinitely many solutions, guys. And instead of writing that out in words, sometimes we write the little sideways 8. It's an infinity symbol. Okay? Infinitely many solutions. So case 3, I'm going to write my variable terms. Let me just write this. You all need to be taking notes. Your variable terms cancel. On both sides. And you all pause the video and write this down right now because I need to erase this infinitely many solutions because it's in my way. Let me just put it over here. All right, so in this particular case, your variable terms cancel on both sides, and the leftover numbers are equal. So that's case 3. So you have two cases. Case 1 is one solution. You just get one answer. Basically, you're going to end up with an x equal to something. Okay? Your variable terms do not cancel on both sides. Case 2 is no solution. Your variable terms cancel on both sides, and the leftover numbers don't equal. Case 3 is infinitely many solutions. Your variable terms cancel on both sides, and the leftover numbers are equal. So when it's no solution, when it's no solution, there are no possible numbers that could work as a solution to the equation. But when it's infinitely many solutions, well, I didn't want to do that. When it's infinitely many solutions, every number could work as a solution. It doesn't matter what you put in for x. The left side will be equal to the right side expression, okay? Let's take a look at some examples. I normally have my students try all 4 of these. So if you think you get the gist of what I was saying, or you understand, comprehend what I was trying to tell you in case 1, case 2, and case 3 above, then pause the video and try these 4, okay? All right, this is what you should have for number 1, or should have gotten. 3 times 2x is 6x. 3 times 2 is 6, and then bring down the negative 3x. Here, bring down 6 plus 3x. So on this left side, I can combine like terms. This goes to the right. This goes to the left. So I'm going to subtract. 6x minus 3x is 3x. And bring down plus 6. Okay, I'm going to show you something already. You got the same variable term, and you got the same number. Basically, it's the same expression on both sides. So it doesn't matter what you put in for x. The left side will always equal to the right side because the expressions are exactly the same on both sides. But I'm going to solve this thing all the way out and get rid of one of the variable terms by changing the sign. But what happens is the variable terms cancel. And the leftover numbers are equal. So when the variable terms cancel and the leftover numbers are equal, we say there are infinitely many solutions. Okay? And that's what you should have gotten for 1. All right, on 2, draw the line. 6 times 2x is 12x. 6 times negative 6 is negative 36. Negative 7 times negative 2x is positive 14x. And negative 7 times positive 4 is negative 28. Well, if I look at these variable terms, they are not the same. Pretty sure I'm going to end up with one solution here, because my variable terms will not cancel on both sides because they're not the same. So I'm going to solve this just by changing the sign on one of these variable terms. I'm going to change the sign of 12x to negative 12x. These cancel. Sum up with negative 36 equals to 2x, because this goes right and that goes left, or 14 minus 12 is 2, minus 28. Now you got a basic two-step. So you're going to add 28 to both sides and use SAS. This goes left, that goes right. I end up with negative 8 equals to 2x. When it's mashed together, it's multiplication, so I'm going to divide. When I divide by 2, I get an x of negative 4. That's my one solution. Let's take a look at 3. And make sure you're pausing the video, guys, and taking notes. All right, if you take a look at 4, I'm going to use the distributive property on both sides. So 8 times 5x is 40x. 8 times negative 3 is negative 24. 6 times negative 3x is negative 18x. And 6 times negative 4 is negative 24. Now I'm going to show you something. These two variable terms are not the same. I'm pretty sure I'm going to end up with one solution again, because my variables are not going to cancel. All right, so what I want to do is get rid of one of these variable terms. I'm going to get rid of the negative 18x with a positive 18x. Then I have a basic two-step. So I'm going to add 24 to both sides, change the sign of the number that's farther away. So we end up with 58x equals to 0. Now, when you divide 0 by anything, you just get 0. So x is equal to 0. Just because x is equal to 0 doesn't mean you put no solution. The answer to this is the number 0. Okay? Could only be no solution or infinitely many if the variable terms cancel on both sides. Okay? Let's take a look at this last one. Going to bring down 3x minus 13. Distribute 7 times x is 7x. 7 times positive 2 is positive 14. Use distribution again on this side. Negative 4 times x is negative 4x. And negative 4 times negative 7 is a positive 28. And then I need to combine like terms, because I have some like terms over here. This goes right, and this goes left. And these are also like terms. We're going to take care of these. This goes right, and this goes right. Let me take care of the x terms on that side. 7x and negative 4x, that gives you positive 3x. And 14 and 28 gives you 42. All right, and then we're going to bring down 3x minus 13. Well, I already see something. I notice that this variable term is the same as that variable term, but my numbers are different. But because the variable terms are the same, they're going to cancel on both sides. When I get rid of one, I'm going to end up getting rid of both variable terms. The left over here is negative 13, and the left over here is 42. Here, these do not equal, so we say there is no solution, because my variable terms cancel on both sides. and the leftover number don't equal. Okay? So we say there is no solution. You can also put the little circle with the slash through it. Just like up here, I put the infinity symbol. All right, guys. That's it for the notes today. What you're going to do is you're going to go to the classwork tab and you're going to see homework 3. Well, you'll see where it has homework and it's no solution, infinitely many solutions homework. But there are going to be all 3 cases. Case 1, you could end up with 1 solution where you got an x equal to a number. You could have case 2 where there is no solution. Or you can have case 3 also on this sheet where there is infinitely many solutions. And you can use this symbol for no solution. And you can use the sideways 8, which is the infinity symbol, for infinitely many solutions, okay? But again, it's on your classwork tab. And it is homework number 3, okay? All right, get started on that, guys. And we'll check it first thing tomorrow. Thank you.